Hey, welcome back, students. In this video, I want to go ahead and take some time to explain how to calculate the molar mass. But before we begin this discussion on how to calculate it, let's go ahead and ponder the goals for the lesson. In this lesson, I want you to focus on two main goals. I want you to focus on understanding what the mole is and what molar mass is. I also want you to focus on understanding how to calculate the molar mass, especially when we get to the portion of this lesson where I explain the specific steps on how to do so. Because if you learn those steps, you'll be able to figure out or calculate the molar mass for any given compound that's provided for you within this course. So let's begin. The first question would be, what does molar mean? Well, molar is not going to be a tooth like many of us might be familiar with. But molar in this course refers to a quantity or an amount, very similar to the pound or a kilogram. It's a very specific quantity or a very specific amount associated with an object or a thing. In specific, this is going to be associated with a compound in this course. So whenever we refer to molar, what we're really talking about, especially in chemistry, is going to be 1 mole of a substance, because that's how we're going to refer to it here. Now keep in mind that mole, as we had previously discussed it, is an amount specifically associated with 6.022 times 10 to the 23rd atoms of any specific compound. And so the individual who shared that with us was Amadeo Avogadro when we spoke about Avogadro's number. And so we spoke about that in a previous class discussion. And so that will be the basis of our discussion here with respect to molar and the concept of the mole. So what does mass mean? Well, mass generally is going to refer in this course to how much of an object you actually have, or rather how much matter an object contains. And we're going to measure this using the unit of grams. Sometimes we're going to use kilograms, but mostly we're going to be focused on grams. Now, the next question we need to ask is, what does molar mass mean? Well, now that we've actually looked at both of these terms, both molar and mass, when we put them together, we should come up with a very good meaning. Now, keep in mind that molar refers to the mole of a substance, and mass refers to how much matter an object contains when measured in grams. Therefore, the molar mass is simply the mass in grams of a mole of a substance, or it's going to be the mass in grams of a compound, or rather 1 mole of a compound. But how do you go ahead and actually calculate this? Well, to find the molar mass, the steps you need to take are the following. You simply need to add up all the masses for all the atoms in the compound, and that would be your molar mass. This is also called formula mass in other class discussions that we've had. So just make sure that you understand that both of these are the same. But for this video lesson, we're going to be calculating molar mass. And in order for us to do so, you need to make sure that you take into account the mass of each and every atom within the compound. So let me provide you an example. Here we have an example of water. And the formula for water is going to be H2O. And so what we want to go ahead and do first is we want to make sure that we go ahead and write the formula down. Now, if this is provided for you already, no big deal, just write it down. However, what you're going to find that in this class, I'm going to give you word problems. And because there are word problems in the class, you're going to need to know how to translate that into a formula. And once you've got that formula written or ready to go, you want to go ahead and write it down. The second step is you want to go ahead and identify the different elements in the compound. So in this particular example, we have 2 different atoms, or 2 different parts. The first part is going to be the part associated with hydrogen. I've already gone ahead and identified it here and highlighted it in red. That represents the first part of the compound water. The second part of the compound water is going to be identified by the oxygen. And so this is the second part. And what is left for us to do now that we've identified the different elements in the compound is we then need to go ahead and identify how much mass is associated with each part within the compound. But we first need to pay attention to any subscripts within the formula. Notice here we have a 2. The 2 refers to the hydrogen in the compound, specifically the atom immediately to the left. So the 2 is between the hydrogen and the oxygen symbols, but in this particular problem, the 2 refers to the H, which means that we have 2 hydrogens in the compound, and the oxygen, because it doesn't have any number associated with it, simply means that we have 1 oxygen atom. But let me go ahead and rewrite these in a slightly different manner. It might help you out when we're trying to figure out the total mass for each one. Notice in this case I put the 2 and the 1 inside parentheses, because what we're going to do is we're going to get the mass of each of these atoms for either hydrogen and oxygen, and we're going to multiply it times the number of different atoms in there. So in this particular case, hydrogen has two atoms, oxygen has one atom within the compound of H2O. And we're going to go ahead and look up the masses for each of these atoms, and we're going to multiply it times the number of atoms present. And so when we do that, what you notice here is we're going to find that hydrogen has a mass of 1.008 grams, represented here. And since there's two of them, we're going to go ahead and multiply that times 2. Oxygen, on the other hand, only has one atom in the compound, so we're going to take the mass of 15.99 grams and we're going to multiply it times 1. And so when we do that here in long form, let's go ahead and shift this over to the left, but what we're going to find out is if we take the 1.008 grams and we multiply that times 2, what we wind up getting is the following: 2.0016 grams of hydrogen. And when we do that for oxygen, we take the 15.99 grams, multiply it times the one atom in the compound, and we wind up getting a total mass for all the oxygens of 15.99 grams. So now that we've done this, we've multiplied the mass of the atom by the total number of atoms in that compound, we need to go ahead and add up all the individual masses for each of the parts. And that's what we find here. So if we take 2.016 grams of hydrogen and we add that to 15.99 grams of oxygen, the total mass for the compound is going to be 18.006 grams. This is the molar mass. This is also the formula mass for this particular compound. Now keep in mind that this particular mass is what's going to be used in later lessons when we learn how to calculate percent composition. But for right now, this is how you calculate molar mass for any given compound. So as long as you follow these steps in trying to figure out the molar mass of any compound, you should be successful. The main thing that you need to keep in mind is you need to make sure that you get the mass of each and every atom in the compound. So, in summary, what have we learned? We have learned that molar refers to a mole. We have also learned that mass is the amount of matter present for a particular atom in a compound, but it's going to be measured in grams. And molar mass is the mass associated with 1 mole of a substance, or the mass of 1 mole of a compound. So in this lesson, you've learned how to calculate molar mass. Keep in mind that there are future lessons that are coming up. In those lessons, we're going to go ahead and look at other examples of how do we calculate molar mass. So go ahead and subscribe, and we'll see you in the next lesson.